Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Hajanur Yasin Rosli and my metric number is 2017052. Today, my group would like to present our group project which has the title of River Water Quality using PDE. This presentation consists of 5 things which are introduction, mathematical formulation, results, conclusion and references. Moving to the first chapter, I would like to explain 3 things, which is the background of the study, the research objective, and also the research scope. Moving to the background of the study, as we know, water is the most essential element not only for human but also animals and plants. Most of the human body proportion is made of water. Therefore, it is important for us to consume a clean and a good quality of water in our daily life. As river has an unlimited sources of water, it becomes one of the primary sources for the living things to obtain it. However, due to several causes, the level of the quality in the river decreases and it creates the good quality water to become limited. These causes include human activities, which are sewage, chemical waste, and agriculture. Not to forget natural phenomena such as floods, volcanoes, and animal waste. These 2 things are the main contributors to the decreasing of the river water quality. Now we will go to the research objective. This research has the objective to determine the concentration of the river water by applying partial differential equation. This research utilized the advection-diffusion-reaction to calculate the concentration of the river water. This leads to our research scope where we focus on calculating the concentration of the river water so that we can determine the level of the quality in the river water. Next, we go to the second chapter, which is mathematical formulation. This chapter consists of 2 things, which are literature review and mathematical model.
So Assalamualaikum warahmatullahi wabarakatuh. So for my part, I'm going to cover for the literature review and the mathematical formulation. So to begin with, Dr. Jaiswal, he utilized the advection diffusion equation to calculate the river water quality in 2 conditions for the input source, which are uniform flow and increasing nature. And next, study by Marcin Libeli, they use the same approach as Dr. Jaiswal, which is by utilizing the advection diffusion equation, but the differences is the Marcin Libeli they use it for the smaller river lah compared to the Dr. Jaiswal. And for the last part, which is by Tripathi and Katawani, they also use the same model advection diffusion equation for the contaminants and the dissolved oxygen concentration. So as you can see here, this is the model that we are going to use for our project. So in this project, we will be dealing with the water quality in 1 dimension. The model used in the study is derived from the standard advection diffusion equation, has the addition of pollutant Q. The equation, which describes the rates of change of the pollution, concentrations with pollution X, and time t is given by. So to begin with, the mathematical model, so this is the model. So I think to make it simple, the advection is the longitudinal transfer of matter or heat by the flow. Meanwhile, the diffusion is the movement of particles from higher concentration to a lower concentration. I think that's the best thing of science, chemistry, physics in high school. So I think and in this project as well, we consider the model as the steady state. So yeah, so some of the description of the model, which is dP, dispersion of the pollutant, A is the cross section area of the river, and then P is the pollutant, X is the distance of pollutant spreaded, V is the velocity, K is the degradation rate of pollutant, Q is the addition of pollutant rate, and Hx is the Heaviside function with an initial condition as you can see here, and we consider the boundary condition is since it's an open river, so yeah.
Assalamualaikum, I am Abdurrahman bin Azman with method number 2112221. We will continue the presentation with the computer-aided approach to find the solution. So to solve our differential equation, we use the programming tool called Octave, and this is our user-defined function of the river water quality problem from the model before. This is where we define the variables to plug into the user-defined function in the previous code. Line 12 is the command to call the function so that it will return the solution. And lines 14 to 16 is the coding for the command window to plot the graph of the solution. After running the previous code, the graph of the solution that will be shown in the command window is as follows.
Understanding and managing water quality in rivers is crucial for environmental sustainability and human well-being. Mathematical modeling serves as a valuable tool in predicting the behavior of pollutants in river systems. This aims to compare the manual and computer-aided approaches in modeling river water quality, specifically focusing on the 1D advection-diffusion-decay equation. The choice between manual and computer-aided approaches depends on the complexity of the problem at hand. While manual methods may be suitable for theoretical exploration and insight into simplified cases, their limitations become evident when dealing with the intricacies of natural river system. The simplified assumptions and neglect of critical factors in manual approaches can lead to inaccurate predictions and inadequate presentations of reality. Computer-aided simulations, on the other hand, with their ability to model complex geometries and dynamic conditions, offer a more accurate and applicable solution. These simulations are essential for addressing real-world environmental challenges where river systems exhibit diverse characteristics and behaviors. However, it's important to note that the accuracy of computer-aided results depend on the precisions of input parameters, proper model calibration, and validation against observed data.
Assalamualaikum, and I am Nur Fazil binti Maifar, matric number 1912574. Okay, here I will present about chapter 4, which is conclusions. In conclusion, we can say that this of river water by applying PDE or partial differential equations, and we have used a one-dimensional advection-diffusion-reaction equation, which is a mathematical model that describing transport and diffusion problems such as pollutants and suspended matter in a river or canal. This mathematical model has been widely used to forecast river water quality and provide reliable methods for regulating its quality in impacted regions. In addition, this PDE using two methods to get results. And the first method is manual approaches, whereby it is offer insights into specific scenarios, but their applicability is limited by the complexity of real-world river system. And second method is computer-aided simulations that offer a more versatile and practical solutions. And hence, this study primarily focus on recent development in mathematical models that allow for prediction of river water pollution concentration levels. Thus, we believe these mathematical studies would allow for better planning for water quality regulations. Okay, now let's talk about we relied on 4 articles for this project and this literature review.